This is my application as required for CA1 of Internet Security. The purpose of this application being to take a piece of text which is entered by the user in this case, as you can see down here. It's waiting for user input, and we're going to encrypt it using variations of DES such as ECB and CBC. Okay, so if we just look through the code, you can see these are the variables that I've decided to make global. So I decided to make the key a global variable so that the differences in the resulting ciphertext would be purely based on the differences on the encryption methods and not because of the difference in the key that the text was encrypted with. And same with the initialization vector. I decided to make that global as well, so that it's only required for CBC. So just so the CBC ciphertext would be, the differences would be purely because of the way it was encrypted. Into the main method, you can see here that the security I've actually added isn't the provider I'm using isn't actually the Sun JCE, and this is because I've decided to use the Bouncy Castle JCE because I was investigating it as for its utilities in regards to key generation, storing and distribution, as required by the CA. I think it was question 5. So because I was looking into it for the rest of the CA, I decided it made sense to use it for encryption. And you can actually see over here some of the classes that it actually uses. It uses key generator, so like it just has a lot more utilities for the key generation, storing and distribution than the Sun JCE had. Now if we go in, so right now it's looking for user input. So if I just type in it's just going to encrypt it, and you can actually see that this is the output. So you can clearly see the ECB with padding, CBC with padding, no padding, and no padding in both cases as well. If we just go to those methods, you can see this is the encrypting the string using ECB. So we pass in the user input, and we see that this is the cipher. This is me setting the Bouncy Castle provider. The encrypt mode, this is the key, it's the global variable, so that we know that any differences is going to occur because of the way that ECB and CBC are encrypted. And then here we're declaring that the array is the same size as the input from the bytes that we've actually stored up here. And then we return the resulting array back, and then we get this output here. And now we pass in this array here from ECB. We pass that back in to decrypt it, just to ensure that we're getting the right that we're encrypting it correctly. The only way to make sure that we're encrypting correctly is to decrypt it as well. So again, make sure that we're using the same padding. The provider is the Bouncy Castle. We're in decrypt mode now, and we're using the same key. And now we're trying to get the plain text, and then returning that, and we can see that we were correct because we have the same output. And similarly with CBC, the difference being that now we're using an initialization vector, and that's the only real difference in the code, is the initialization vector between the two, and it's encrypted the same. The initialization vector being used up here, so they're the same. And then we decrypt it, and this is how we get this output. And you can see that these are the differences in the ciphertext here and the ciphertext here. We can clearly say that they are actually because of the differences in the way that they were encrypted, and not because of the key, as the key was the same for both of them. So the differences is purely because CBC was encrypted with the initialization vector, and not the same way, not with a ECB. Now if we take a look at the no padding one, let me just go down here, we can see, well, first of all we can see that the ciphertext for ECB, it has a lot more of the same characters than with CBC, and that is because we're not relying on initialization vector for ECB. So again, very similarly, the only difference being that we're using no padding. It's still DES, ECB, no padding. And then it's all the same as above in the others. And same, now we're in decrypt mode, and we're using the same key that we're using for the padding as with no padding, so that all the differences that you can see here are because of the differences in the encryption methods, and it has nothing to do with the key or the initialization vector in either case. Same down here with the CBC. And now for the test cases, I've chosen to test the ECB, all the encryption and the decryption in both the ECB and the CBC. So if we run that file, you can see that all the tests have passed, and if we look inside it, I'm just doing a hello there, and you can see this, and then the expected result is the cipher, and this is the result, and then we assert that they're equal to both of them, and all of these are the same. Again, for sanity's sake, I've made the key global, so that in every case it's going to be the same, and all the differences will be because of the way it's encrypted. Thank you, that is my CA1 presentation.